Welcome to a new video about the mysterious and fascinating universe. We hope you enjoy it as much as we do, and we kindly ask you to subscribe and like this video so we can continue bringing you more content and memes. Now let's begin. The scientist mission has once again generated great attention with his recent claims in the scientific community. This time, he has revealed rigorous studies and scientific projections that have determined with high precision the nature of black holes. In his latest statements, he highlighted the following: when a black hole rapidly rotates, which is common in space, its singularity is not a point but a ring. Surprisingly, if someone were to fall through that ring, they would experience spaghettification, a stretching effect, and face certain death. Most of us imagine a dark and absolute void when we think of a black hole. However, in reality, black holes are quite the opposite. It has been shown that within these objects, in their deepest regions, lie the points of maximum density in the entire universe. In this video, we will unveil some of the mysteries surrounding these celestial bodies. For example, we will explore some of the claims made by the scientist who asserts to have discovered what lies inside a black hole. We will also provide a comprehensive description of how a black hole is formed and detail the differences between supermassive black holes and other types of black holes. But before delving into these aspects, let's start by defining what exactly a black hole is. According to NASA, a black hole is an astronomical object with such intense gravitational force that nothing, not even light, can escape its attraction. This fundamental characteristic has given rise to its revealing name. Throughout history, it has been difficult to determine with certainty whether black holes exist or if they are merely theoretical. They are invisible due to their lack of light emission. However, thanks to technological advances and new methods of calculating celestial objects in space, it is now possible to detect the radiation produced when matter is pulled towards a black hole through the electromagnetic spectrum. It is important to note that black holes have a finite size and a spherical surface known as the event horizon. This surface envelops the body of the black hole and marks the boundary beyond which matter and radiation are trapped, unable to escape. Normally, black holes are relatively small, although their extreme density makes their mass much greater than that of similarly sized stars. Despite their apparent small size, a black hole formed from the remnants of a dying star can have considerable mass. In the past, it was believed that black holes were enormous stars much larger than our own sun, with estimated sizes 10 to 15 times its magnitude. During the final stage of their lives, these giant stars explode in a tremendous and powerful process known as a supernova. In this explosion, the star violently expels its outer layers into space, while its core succumbs to gravity's attraction in an equally violent manner. The core does not have enough strength to resist gravity, resulting in the collapse of the former star upon itself, becoming increasingly denser. It is in this process that a black hole is formed. However, it is important to note that not all stars become black holes. Only those with greater mass have this fate, while others end up as white dwarfs or neutron stars, according to researchers and scientists. Although we cannot see the black hole itself due to its darkness, there is a bright gas in the form of a ring that allows scientists to identify and study them. As mentioned earlier, the gravity of a black hole is so intense that not even energy can escape from its interior. Any object that comes close enough to the black hole will be pulled by its gravitational force. If it crosses the event horizon mentioned at the beginning of the video, not even light can escape it. Once an object crosses the event horizon of a black hole, it is trapped and inevitably pulled towards the singularity at the center. The singularity is a point of infinite density where the laws of physics, as we currently understand them, break down. This is where the laws of general relativity and quantum mechanics collide, leading to a realm of unknown physics. According to the physicist Stephen Hawking, black holes are not entirely black. They emit a faint radiation known as Hawking radiation, which is a consequence of quantum effects near the event horizon. This radiation, though extremely weak, carries away energy from the black hole and gradually causes it to lose mass over an extremely long period of time. Eventually, this process leads to the complete evaporation of the black hole, but on a timescale far longer than the current age of the universe. In recent years, there have been significant advancements in our understanding of black holes, thanks to groundbreaking observations and theoretical developments. One of the most remarkable discoveries was the detection of gravitational waves, ripples in the fabric of space-time caused by the violent mergers of black holes. This discovery was made possible by the Laser Interferometer Gravitational Wave Observatory, LIGO, and other gravitational wave detectors. The study of black holes has also revealed different types of black holes with varying masses. Supermassive black holes, as the name suggests, have masses millions or even billions of times greater than that of our Sun. These enormous black holes are believed to exist at the centers of most galaxies, including our own Milky Way. Their formation is still a subject of active research, but it is thought that they grow through a combination of accretion of surrounding matter and mergers with other black holes. On the other end of the scale, there are stellar mass black holes, which have masses several times greater than that of the Sun. These black holes are formed from the remnants of massive stars that undergo supernova explosions. They can be detected through their interaction with nearby matter, such as pulling gas from a companion star, creating an accretion disk that emits X-rays. There is also a hypothetical type of black hole called a primordial black hole, which could have formed in the early universe shortly after the Big Bang. These black holes would have very small masses, ranging from microscopic to asteroid-sized. Although they have not been directly observed yet, they are the subject of ongoing research and could provide insights into the early universe.